All right, let's look at the exact equation. All right, exact equation is constructed starting with a solution. Then we try to find the differential equation whose solution is the solution we start out with. All right, let's look at it. All right, so let's say you have a solution f of x comma y equals c. C is just a constant. All right, so let's take the derivative. So if you take the derivative of say with respect to x, right? Take the derivative with respect to x. All right, since capital F is a function of two variables, so what you do is we take the partial derivative of f with respect to x, and then multiply by derivative of x with respect to x, which is going to 1 anyway. And then we take the partial derivative of capital F with respect to y, then multiply by derivative of y with respect to x. And the derivative of the right hand side is of course 0, since c is a constant, right? So you can just cancel those, right? And what we want to do is we're going to actually multiply through by dx. Oh, I'm going to use a different color. All right, multiply through by dx, so that we have this form. So you have a partial of f with respect to x dx plus partial of f with respect to y times, so dx cancel out, so you're going to get just a dy. And then 0 times anything is 0. Right? So this equation is called the exact equation. So maybe I'll write that down. So this is the exact differential equation. I'll just say exact equation. Right? And so this differential equation will have a solution f of x comma y equals c. Right? Then what we want to do is we want to have some kind of way to recognize exact equation, right? So mostly, if you look at this part, right, in general, this is going to be written as a function of x and y, right? And this guy is going to be also some function of x and y, so I'm going to call it n of x comma y, right? So if you have a general differential equation, say mx comma y dx plus nx comma y dy equals 0, then we want to know if this is actually an exact equation. So here's the a good way to tell something is an exact equation. This is called Exactness Criterion. Right? We say m times dx plus n times dy equal to 0. Right? It might not be exact, but we can make sure that it's exact if and only if partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Right? We're not going to go through a proof or anything, but since mx, if it's an exact equation, it's a partial of x already. If you take the partial of m with respect to y, you are actually looking at the second partial of f with respect to x, then with respect to y, right? And if you look at the partial of n with respect to x, but the partial of n is already a partial of f with respect to y, so if you take the partial with respect to x, it's going to be a second partial of f, and with respect to y first, then with respect to x. Right, so you can see that the left-hand side and right-hand side are both mixed partial, second mixed partial, so they're equal to each other. So it makes sense. So when you have these partials equaling each other, we know that this is an exact equation. All right, that's it. I hope that this was clear.